Size of branch circuit and feed cable. The calculation of lighting and socket branch circuit can be done as follows. Lighting load and appliance load with specific load calculated as actual installation. General socket, calculate each socket at 180 volt amperes for 1, 2, and 3 sockets. Specific socket, calculate as the actual of load of appliance. There are two types of load in branch circuit, i.e. continuous load and discontinuous load. Continuous load means the load operates more than 3 hours. If the type of load is unknown, you should calculate them as continuous load in case of the combination of both in a branch circuit. Branch current equals discontinuous load current plus 1.25 times continuous load current. Example. Calculate load current as in the following electrical plan. Load in circuit 1 is equal to 180 times 7, or 1,260 volt amperes. Load current is equal to 1,260 divided by 220. Branch current is equal to 5.73 times 1.25, or 7.16 amperes. Choose 10 amperes of branch protective device. Choose the wire size in branch circuit in case of wire installation using clip. See table in module of electric wire is column Hawkeye. Then we get the wire size 1 square millimeter, 11 ampere. But the wire from branch protective device, choose the minimum at 2.5 square millimeters. There are 8 units of 40-watt fluorescent bulb. Incandescent current equals quantity 4 times 100 divided by 220 is equal to 1.818 amperes. Fluorescent current is equal to 8 times 0.43 is equal to 3.44 amperes. Total current is equal to 1.818 plus 3.44 is equal to 5.258 amperes. If continuous load is equal to 1.25 times 5.258, branch current is equal to 6.57 amperes. Choose 10 amperes of branch protective device. Choose the wire size in branch circuit in case of wire installation using clip. See table in module of electric wire is column Hawkeye. Then we get the wire size 1 square millimeter, 11 ampere. But the wire from branch protective device, choose the minimum at 2.5 square millimeter. Branch circuit refer to the regulation of electricity authority. 1. Branch circuit 5, 10, 15, 20, 30, 40, and 50 amperes as the size of overcurrent protective device. The mentioned size, if not matched the standard of manufacturer, the next size can be used. 2. Branch circuit 5 ampere, 10 ampere, 15 ampere, and 20 ampere. When permanent load installed with socket-type appliances, the total load of branch circuit must not be over 50% of branch circuit, and the load of each socket-type appliance must not be over 80% of branch circuit. 3. 30 ampere branch circuit is a large branch large circuit. It is forced to use lamps connected to the circuit not larger than 660 watts, or use with plugged socket. But the size of each appliance must not over 80% of branch circuit. 4. Sub-circuit size 40 ampere and 50 ampere sun lamp installed in the circuit cannot be larger than 660 watts, as sub-circuits 30 ampere, but appliances are connected in a circuit must be permanently installed only. Do not use a wall socket and plug. 5. Calls for the circuit size small. Calls for the sub-circuits must be of sufficient size to pay for the electricity load in the sub-circuit, and must not be less than the current size over current protector sub-circuit. However, the sub-circuit size line must not be smaller than 2.5 square millimeters for the requirements of the MEA and 1.5 square millimeters for the requirements of PEA. Calculate the feed. The feed cable must be sufficient size to feed the current to every sub-circuits. the flow of feed cable obtained by adding all of the load in the feed line together. The current is calculated the same way as sub-circuit line. Total load is equal to discontinuous load current plus quantity 1.25 times continuous load current. Size of feed line. The designer may not use the demand factor if the power that may be used simultaneously, full 100%. However, the feed must be no larger than 4 square millimeters for specific terms of the MEA and 2.5 square millimeters for definition PEA calculated using the following demand factors. Vocabulary: Metropolitan Electricity Authority, MEA. Provincial Electricity Authority, PEA. Engineering Institute of Thailand. Branch circuit. Amount. Allowance. Radiation. Permanently. Regulation. Various. Simultaneously. Prohibit. 1. Light load. Use the factor demand in the table. Demand factor from the table for lower maximum power demand of electricity consumption in various locations of the feed, because some places may not be enabled at the same power. So it be scaled down to save feed line costs. In some cases, the lights may be used simultaneously, such as the cafeteria hall do not use demand factor. 2. Loads of the wall sockets in other places, non-residential use the demand factor in the table but on a general purpose outlet. 3. If you know the other outlet D, consider the maximum load from the socket outlet plus 75% of the rest. Calculate load by using demand factor shall apply to the feed line, but for the subcircuit is strictly prohibited. In the case of housing, demand factor should not be used in the load calculation unless in the utility or plant. Because in the large system, if you think there are loads of much use to the full 100%, it will be consumable costs for installation of main system. 4. Dimensions prevent the feed line. When the size of the feed stream, then select overcurrent protective device that can load all of the calculation. Then select the feed size to the value of not less than the current value of the guard. Summary of hierarchical design is